everyone to two closing panels on really forward-looking topics. The first one will discuss how we can reach global 3D mobile network coverage. It's led by Ericsson with great panelists, and I hand it over to our moderator, Morgan Lindqvist, researcher digital airspace at Ericsson. Please join me and bring in your panel.
Thank you. Welcome, panel.
I'll be here with my audience questions, Morgan.
Sounds excellent. Thank you, everyone, for coming. I'm really looking forward to this afternoon and the nice discussions we will have here. My name is Morgan Lindqvist, and I'm here to talk about how we can save lives, at least in one sense of what we are doing. The thing that we are going to talk about mainly here is digital airspace. And the digital airspace will then enable connectivity to drones when they're flying beyond visual line of sight, so far away, so not close to you. We're also going to cover a bit connectivity to airplanes and helicopters and how we can improve the communication and reliability when talking to them. We have a big panel here today, which is really excellent. Let's start at the far end with Elmar. Could you present yourself?
Yes, thank you, Morgan. Yes, I'm Elmar Trocher. I'm working at Ericsson with the coverage technologies around mobile communication systems. I'm a stand-in for Katarina Lindholm that unfortunately got sick, but we're working together with Saab on some interesting projects that you will also hear about. So,
thank you. And then we can move over to Erik.
Thank you. My name is Erik Nordell. I'm also from Ericsson Research, working as a manager mainly then on the physical layer on the radio research.
And then Daniel.
I'm Daniel Tischlerets. I'm CTO at Terracom. I hope I'll get more chance to elaborate on Terracom later on. I don't think so many know what Terracom is, but I'll come back to that.
Sounds excellent. And then we have Cicek.
Hello, I'm an associate professor at KTH, Communication Systems Division. I have been driving research in the area of aerial communications, 3D communications, basically connecting flying things for the last 7 years. Thanks.
Thank you very much. And I started this panel discussion with saying that we are going to save some lives. And then the question is, Daniel, do you have some use cases that can apply to this, or what are you doing otherwise as well?
Yes, I can do that. Let me take the chance now to shed some more lights on Terracom. Terracom is a state-owned company in Sweden that has a background in public service distribution, which means that we sit on a quite robust infrastructure with high towers, where we have established our air-to-ground network. And there we are now, this has been concluded and established just recently. So now we had some early tests and proof of concept with aircrafts, both with the police, with the Swedish Coast Guard, where we actually are using our air-to-ground network. We're also in an early dialogue with the voluntary Swedish air squad that is up and on part-time detecting also forest fires. And all this to enable a better communication environment with them, with the increased bandwidth and better capability of transmitting critical information and situational updates.
Thank you very much. Elmar, any other use cases that you see that we can enable now that we have good connectivity to beyond visual line of flight, both for drones and for aircraft and so on?
Yeah, so if you imagine that we can have a mobile network coverage upward as well in 3 dimensions, you can think yourself about use cases. There are many of them. One was already mentioned by Daniel, public safety, national security. We can use helicopters, we can use airplanes, drones, to actually have surveillability of areas, supporting the police, the fire brigade, and so on. So it's really about being able to see things and react on it, disaster relief, recovery, and so on. But then you can also think a bit about utilities. If you have power lines that are going all over the country and they're very hard to inspect, if you could have a small unmanned aerial vehicle, as they're called, and send them up to do inspections with different sensors, that would ease a lot the operational expenditures in this kind of area. You could also think, if you go a bit higher in the mid-altitude range, 300 meters to a couple of kilometers, you could also think that in the future we could have air taxis, we could have other autonomously flying vehicles. That's a bit of a 6G long-term vision, but that's also what we look into. And then if you go really high up, you would actually start to see commercial aviation, airplanes that all of you are using. They're also in need of connectivity to fly safe, to make a good performance, also be cost efficient. And then another area which is important, if you will or not, is peacekeeping and defense. And there we also see that there are applications in the airspace which are at least researched and tested.
Thank you, Elmar. Now we know what we can do or what we would like to do. Then the question is, okay, how can we do it, and what's the technical solutions that is required to enable this? So we heard here about that we have both satellites and then we have terrestrial ground communication networks. So if we start with the satellites, Eric, what technical solutions are we working on, what exists, and what we have in the future going forward?
Yes, it's happening a lot in the satellite domain. Of course, everyone have heard about Starlink and those sort of things. All of that is built upon proprietary standards, but it's also now coming into the normal mobile standard for the mobile phones that all of us have. So that is something we are working with, and in this case we see it mostly like a complement to the normal terrestrial mobile networks that we all are using. So I mean, it will not be as powerful directly to your phone, but I mean, going forward it will be possible to make a call directly to your phone wherever you are. So independent, if you are in the middle of the Atlantic or in the high mountains or something like that, you will be able to do that. And of course there will also be data services. Then you can see, of course, different technical solutions here. This is what you can do with a mobile phone. There are technical solutions due to the form factor, so you can't do everything with it. There are physical limitations. Then you can, of course, do things with better antennas, etc., like what you see in the Starlink case, but still using the same sort of satellites. So this is a domain we are looking into together with other companies, and we are doing the standard here as well to create this ecosystem, and not at least to build upon this ecosystem, which is the largest ecosystem you can think of.
That sounds excellent. Think about calling your mom, telling that now I'm halfway over the Atlantic, call you when I reach US. Thank you. On your own phone and not on the really expensive in-flight phone on the airplane, of course. If we take the other area, then the more ground-based, what is the challenges here and going forward? Daniel, could you say something from the Terracom point of view on the technical solutions you have?
Yeah, but the background and what Terracom have leveraged being a provider of broadcast for a public service, Swedish radio and TV, we have leveraged the high-rise towers that we have. Normally, in a mobile network, terrestrial mobile network, the antennas are around 30 meters high. We have towers between 150 to 300 meters. So we have leveraged this altitude capacity and then mounted antennas accordingly much higher up in the air, which means that we have provided a slice of coverage in the airspace. The challenges, of course, with that we have is with potential interference. If you would leverage the same type of spectrum on the ground as in the air, that's why you need to review spectrum partition tactics. So you leverage a certain frequency or a slice of a frequency in the spectrum for the airspace. And then you need to have another one on the ground level. And of course, there could be challenges when you do transition from the airspace down to the ground level with interference. So this is something we're exploring right now. We're in an early phase. As I said, we've just deployed this network, and we are working with the first initial trials. But I say one challenge is you need to have a high-rise towers to get up in the air to provide the right altitude of the coverage, and then also the spectrum partition and interference is technical issues that you need to consider.
Mm-hmm. So going a little bit follow-up questions there. How many towers do you need? How much of Sweden do you cover? Is that something you can share with us?
I wouldn't go into the exact details, but I could say we are the first, with confidence can say, in Europe that have launched this type of networks. We haven't found references globally either, but with confidence I can say in Europe we have launched it. And you could say you would be surprised that there's not that big amount of towers that are needed, because we talk about free air propagation with very low losses. So you have good coverage from one single site.
Thank you very much. Zizek, from a university perspective, what's your view of the current technical solutions and what you think would be needed going forward?
Yeah, thanks. Yes, first, if we think about providing connectivity to the flying taxis, for example, a little bit more futuristic use cases. The command and control link is very important for beyond visual line of sight connectivity, especially for safety. So that requires very high reliability. And providing that link continuously without any interruption during the flight of a vehicle is still a challenge. We have done a lot in terms of interference management. Basically, those networks, our current terrestrial networks actually are optimized for ground users, not for flying users. So our antennas are tilted down. Interference management is based on user in the 2-dimensional space. So here we talk about a 3-dimensional space interference. Sometimes you end up a drone transmitting and blasting power towards the ground. If there is a spectrum shared between the ground users and the flying user, it's impossible to basically maintain the quality of the connection because it will interfere, basically. So it's a different type of environment, and challenges need to be considered differently than the traditional terrestrial networks. For example, interference management, in addition to the interference management, handover management is also another problem. As a UAV is moving between one base station to another base station, there are so many line of sight connections, around. And it's not that it can be complicated. It's not that simple to select which is the best connectivity, because there is a speed, environment is quickly changing, and you don't want ping pong and very fast and too many handovers. So you need a stable network, stable connectivity, and we have been developing last 5 years this type of intelligent mobility management algorithms, mechanisms to support this type of services, and also interference management by using mainly machine learning and reinforcement learning and optimization techniques. When it comes to the airplanes, if we go up a little bit for the 13-kilometer range, there is European aviation network already. with the leadership of Deutsche Telekom. Now in Europe, there is a solution, direct air-to-ground connectivity solution provided, but of course not as good as the deployment that we have in Sweden. Distance between base stations are quite large, and the quality is not that good, but still delays are much better than the satellite. Existing satellite connectivity has a lot of delay. So in Europe, we are now maintaining kind of good quality direct air-to-ground links to the airplanes, but still with the condition that there shouldn't be that many passengers using it at the same time. So still there's a lot of research to be done in this field.
Thank you. Could you just shortly describe what a handover is? Maybe not everyone here knows that.
Okay, yeah. When a mobile user is moving between one base station to another base station, it needs to disconnect from the host base station and connect to the next base station. So we have different types of handovers, but handover is the mechanism to manage this soft transition between one base station to the another base station, basically. Yeah.
Thank you very much.
You're welcome.
If we then go to the mobile networks, how do you see the mobile networks to support digital airspace, Elmar, over a longer time period?
Yeah, as Zizek said, the situation in having UAVs, so these aerial vehicles, is a bit different from what we have on the ground. It's a very large span of different velocities, so you can have drones, you can have helicopters going 100 kilometers per hour, 400 kilometers per hour. We can have jet planes going above 1,000 kilometers per hour. Also, as we said, this mobility that we would see up there is something that can be very rapid compared to what we see maybe on the ground, even with the high-speed trains or with fast cars. So there we have worked quite a bit in updating and upgrading the standard, and also the products to support this as well, or we're about to do this. So another large problem that we see that we are getting solved now is also interference in the same spectrum, especially when you go a little bit higher in altitude. And this is to maybe have even dedicated digital airspace networks. So what we see is that if you would like to supply the coverage to low and mid altitude terminals, then it's good enough to enhance the existing operator networks by, for example, running on side lobes on the antenna, creating interference. But if you then start to go higher up, you can have an own dedicated network. And there we have really a golden nugget in our toolbox, which is called MIMO. Multi-user MIMO, and that grows in capacity and also grows with performance the more space you have, the more volume you have, spatial diversity. And that actually is showing, if you go up into the airspace, that you get more capacity out of the systems. But it's heavy signal processing that you need to implement there. But we're positive that we will get this to work decently, or very good in the end.
Yes.
I can maybe complement there.
Yes.
One thing I forgot to say regarding challenges, and when Elmar starts to talk about speeds, I recall it's about the Doppler effect, meaning that we are working also with aircraft flying higher than 380 and 400 kilometers per hour, which is the limit in today's standards, 3GPP standards, for the maximum speed that can be managed in a mobile network. So there we have seen a challenge with I don't have to mention, I think you can guess what type of aircrafts are flying faster than 400 kilometers per hour. And the Doppler effect is an impact of frequency changes in those speeds, which with the radio standard today is unable to cope with that. But together with also in a dialogue with Ericsson, but also there are other solutions now on the market we have explored from North America that can actually be a workaround to cope with this challenge of high-speed aircrafts, so you can maintain the line of communication even in speeds beyond 400 kilometers per hour. And this is very much sought after for some of these use cases for obvious reasons, I would say.
Thank you very much. I think we have a question or two.
We have two questions. One is, how far is full connectivity, for example, on oceans? And the other one is, what is happening with the number of frequencies available, and is the number of frequencies still an obstacle to further innovation?
Okay, maybe Eric can start with the first one. When we will have, when can I make a call on the middle of the Atlantic?
It's hard to say exactly when that will happen, but I think it's quite near in the future. A few years' time, hopefully, that could happen.
That sounds excellent. And Elmar, then, frequency. Do we have abundance of them, or do we
really good question. So the idea is to reuse the same frequencies also in the digital airspace. As I said, if you go not too high up, you can actually reuse the existing operators' networks with some tricks and enhancements. Higher up, maybe a dedicated network with maybe even dedicated frequency if available. But also what you need to understand is that spectrum is a very scarce resource that we have for mobile communication systems. We need to make sure that we use all the signal processing to maximize the spectral efficiency, as this is called. So the regulations around spectrum are progressing for digital airspace. It's going a little bit slowly, but it's catching up. And basically what you can see that in some countries, you're allowed to just use the digital airspace as you would do with terminals on the ground. For example, in Germany, in Belgium, Denmark, Sweden as well, there is not really a big difference. Some countries are actively allowing this to happen. Some other countries haven't made up their mind yet. For example, America, Canada, USA, Canada, and then also there are some which are explicitly forbidding it, like Switzerland, for example. And that is also then combined with some security regulations, as we said. But yeah, the spectrum will be there to do this, but the regulations need also be in place to allow us to do it as well. But it's progressing.
Thank you, audience. And if you have any more questions online, they are more than welcome. Going through, talked about the technical solutions, maybe what are the remaining challenges? The question is, what's left to solve? What is the challenges going forward? And when it comes to connectivity and using the approach that you in Terracom are using, what kind of challenges do you see going forward, Daniel?
Beyond the one I mentioned, we could also look at the terminal side. I wouldn't say on the terminal side that we have purpose-built UEs, user equipment terminals for aircrafts. Going forward, I envision that needs to be part of the initial designs of the aircraft to have this communication platform, if not enabled, at least physically installed in the aircrafts, so it's easy to enable. Now we are doing purpose-built solutions, and the aircrafts where they're going to be fully operational, they need to do a lot of testing. It's a very sensitive area to bring in new, especially equipment that radiates inside the aircrafts. That's very sensitive. So I foresee that this is a challenge that needs to be dealt with if this is going to be fully industrialized going forward.
Thank you. So now we heard some of the challenges and solutions for part here, but the ecosystem is much wider. And what do you think, Zizek, is the view going forward from an ecosystem and challenges? What's needed to make the whole system fly and be useful?
Yeah, it's a very good question, actually, because we have done a lot when it comes to the technical solutions. We started with research in universities and then in standardization bodies. Most of those research results are already considered, and there are technical solutions, bits and pieces here and there. We develop solutions for handover management, for example, interference management. It's not that we don't have those technical solutions. I think this is an area where safety is very, very important. And authorization, certification of these flying things, the risk is very big when they are unauthorized or when they fall down. If any command and control link is missing for 2 seconds, there might be some accidents, crashes, and so on. So risks are very high. So I think trust between stakeholders and governments, regulatory bodies need to be built in with the industry together. I think this is very important. And the human aspect is also very important. I mean, not everyone likes to hear those puzzling, noise-making things flying on top of their heads. So we definitely need very clearly defined rules and make people feel safe. So still there are a lot of technical challenges, but I think for anything to happen, I mean, even the first step, we need a lot of work in terms of regulations and trust.
Thank you. So we heard a little bit about use cases, technical solutions, and some of the challenges. The question is if there is anything else that needs to be fixed before we can start using digital airspace. And then I'm thinking, Daniel, in your area, identification of drones, corridors, is that something you are using and taking into account, or do you have other challenges going forward when it comes to actual flying of multiple aircrafts in the sky?
Even though our focus has been on aircrafts, which there are today fewer of than potentially you could see drones, we have also been exposed to discussions of connecting drones, and there we see the challenge of the regulatory aspects, especially when you talk about beyond line of sight, that should be connected through one of these networks. And also identification of these drones. Given the geopolitical situation today, you wouldn't like to have unauthorized drones flying. We have also in a collaboration of pilot projects in Sweden of transporting medical equipment and even organs between hospitals with drones. So then, of course, these drones must reach the destination with 100% security. So this is an aspect that I think is still immature. I know it's on the EU level also discussing about the regulatory aspects of drones, identification of drones, giving permission to take off a drone, and knowing in the direction where the drone is going, how congested it is that area. So this is an area that needs to be fully regulated, and also you need to have the technical solution in order to monitor this for this also to be fully industrialized.
Thank you, Daniel. A fundamental requirement, and you were talking about a little bit earlier, Elmar, when it comes to spectrum and regulation, but then we're talking about availability. But if you're looking more global, as the title is on this panel discussion, what's the challenges thinking of digital airspace global scenario and other regulations?
Yeah, so you can imagine that there will be, or there could be quite some objects in the air in the future if we provide this coverage, reliable coverage. This also means that we need to have some traffic management, some control units that make sure that there are no collisions, that it's a safe flight, that we also have planning, route planning, and so on. So one challenge is that given that we have globally many networks out there, we need to have a kind of a standardized, a unified way to get the location data, the position data out of those systems to know, and locate and sense those objects in the air to make sure it's safe. And there we have technologies like digital geofencing, so we know where these corridors are that we can actually program. We can also make sure that we, as Daniel said, are able to identify these users, and that's not just for the traffic management, it's also for optimizing the performance of the systems. So from an interference point of view, it's a very much a difference if you have a terrestrial terminal or one which is aerial. But if you can identify them with a quite good positioning stamp on it, we can actually do much smarter resource management decisions and also handover decisions. So some challenges, but the idea is if you want to make this globally, it's again about how to utilize the spectrum in the best way and how to make it reliable and safe, and to also make it sustainable. That's also important.
Yes,
I have also some words to say. When it comes to the global coverage, spectrum harmonization is very important as you are flying from one country and landing in another country in Europe, especially where we have like many. In a small land, we have many different countries with different spectrum regulations. So spectrum is sliced in different ways, basically. So you can't harmonize the spectrum and dedicate that piece to only like flying vehicles in the whole Europe. This wasn't possible. Actually, that's why, for example, European Aviation Network had to make an agreement with a satellite vendor, because they needed a spectrum and they had to use the spectrum bandwidth in order to have direct air-to-ground connectivity. This is kind of strange, but that's how it is. Otherwise, they wouldn't need a spectrum connectivity. I mean, because there's already plenty of base stations in the terrestrial area, especially in Europe. We are not flying over an ocean, but still, this is a joint connectivity between satellite and direct air-to-ground links, because direct air-to-ground connection is using satellite spectrum, kind of borrowing that spectrum, actually. And this actually brings a lot of cost because all these airplanes, although they are only small airplanes and flying in Europe, they have to deploy these satellite antennas and so on, because this harmonized spectrum is not available. For example, in China, in US, not that big chunk, but still a small slice of harmonized spectrum is available, so that's why they started first. I mean, direct air-to-ground connection started earlier in US, for example, than in Europe. The harmonization is, I think, a key challenge here when we think about the global view.
Thank you very much. Now we heard all of this, and we are on our way to a mass market, but we are not there yet. And since we're not there yet, we need to test things. So test beds is then needed to be able to try out, make sure that you're interoperable and safe and all of that. Eric, my understanding is that you are working on a test bed that can be used when talking about satellite communication. Could you give us some background on that?
Yes. We are building a proof of concept in Ericsson, and that we do together with Thales Alenia Space, which is one of the major satellite vendors in the world, and Qualcomm doing this chipset. They are the biggest chipset vendor in the world. So we together, with the three of us, we are creating a test bed for this, where basically then the Thales is building the satellite part, and of course the Qualcomm is doing the handset part, and we are doing the baseband and those sort of things with the connectivity part in this proof of concept. And we have come quite far on that one. So we were demoing this, for example, at Mobile World Congress last year. So it's happening, I would say.
Sounds excellent. And Katarina, who could not be here today, she is leading a Vinnova project called the Testbed Air Mobility, and Ericsson is a member of that. And that testbed has a goal to be an open testbed, starting being available for external use of other parties after the summer next year, most likely. Timelines, they might shift a bit. What one will be able to do then is to take one's drones, connect it to the testbed, then have it connected to a drone operator that will then steer the drone, and the drone operator will communicate with something called a Airspace service provider, and that's basically a traffic manager for all drone traffic. And there you can take your drone, make sure that it acts, detects, and adheres to all the signaling. If you are in the market of developing a drone operator software, you can take that one, integrate it with the testbed, and so on and so on. So that testbed is there to give the industry of Sweden a boost when it comes to environment to test and to develop things. And we are not only open for companies, of course, but also for government and universities and so on. Elmar, any other experience from building and using testbed in this area that you would like to say something about?
Yeah, I mean, we have been working together with Terracom quite a bit on the air-to-ground network, which was a testbed. So we had several rounds of evaluation there, proving the concept. But then also there are, within a lot of EU projects, or generally external projects, we are, for example, in the Celtic project called 6G for Sky, together with Zizek. We are in the 6G NTN, so non-terrestrial network, low Earth orbit satellite research project. And we also then in a defense project as well, or peacekeeping project as well. And there we see obviously many of these different 3D components coming into the testbed perspective as well. So a lot of things are happening. I think the one that is now closest to reality is what we see in Sweden with this full coverage network. But more to come, I guess. Yeah.
Sounds interesting. So we are now getting close to the end of this panel discussion, and I am the rest of the panel. Hope that you have had that it's been fruitful for you, and maybe increased your knowledge and maybe even sparked some interest. The conclusions I draw from this panel discussion is that it's possible to have communication with flying aerial vehicles already now. You can use the Terracom network, you can use normal mobile operators network. If you have a couple of drones up flying, no problem at all. But to be able to scale on a larger area, as I think it was the previous panel that also said that the regulations is a big hurdle. The aviation regulations, what are you allowed to do, when are you allowed to use the airspace and so on. So that's a big challenge going forward, and not only in Sweden, but also in the rest of the world. Europe is quite ahead here, and we are definitely far ahead of US. All of this, I think, results in that this is a golden time to start building new businesses and services. So if there is any of you out there that thinks this sounds good, I want to enable flying drones, doing this, doing that, and maybe flying a defibrillator from a hospital to a patient out there that have a heart attack, do that. Save lives. It's excellent and fun. Apart from being one of the guys at Ericsson that writes PowerPoint and reads them sometimes, I also at home actually build drones myself, and it's really fun to fly them and learn more and see the challenges firsthand. If you have any questions, more than you already received, we are welcome to take them after this session. So thank you and have an inspiring rest of the day.